stuck with these little things in the way. All right. So 2016, number 5. Part A is asking for the average value. That is a very, very important phrase. The word average, if you see that show up, stop and figure out, is it average rate of change, average value? With average value of the radius, and you're given the equation of the radius, that means you're going to integrate that radius function. And the radius is given with respect to h, and you're finding the average value of the radius when you know that h goes from 0 to 10. So we're taking small increments of h, and then average value says go from a to b, but divide by b minus a. Know that you are allowed to write your integral this way because they did name it as r. And so from there, you don't have a calculator, and it said to find the average value. You have to go through the whole thing. So bringing the actual function r in with the whole thing, I have 1 over 10 times this 1 over 20, and I'm putting them together as a constant multiple. So 200 altogether in the denominator. From there, I'm integrating 3 plus h squared with respect to the variable h. And if you've forgotten how to integrate, because I know it's been a week, constant multiple, integration, multiply by the variable. Use the power rule, add 1, divide by that new number. And lastly, plug in the 10 minus plug in 0, which is going to give you 0. You don't have to write the minus 0. But then you can just leave this as your answer. You do not need to do the arithmetic from there. It's an answer, you're done. Then we move on to part B. For part B, we wanted to find the volume of the funnel. So let me erase stuff from previous. And I'm going to erase this over here as well. Now, as you look at this funnel, you might realize that you have rotational volume about this center axis that's right in the center of this solid. Or you might see circular cross sections. Either way, you're going to come up with the same formula because these circular cross sections have an area formula of pi times r squared. And once you get the area formula, then you look at what is the other dimension, and that other dimension is a tiny little, what looks like a vertical cut, but it's what h is itself. And I think it said it right there. Yep, the h right there. So dh, we'll take that area formula and pop in a volume. We are integrating from h equals 0 to h equals 10. And then you were given the formula for the radius. Now, it does say find the volume of the funnel. It doesn't say not to solve the integral, so you've got to go through this and do the math. So I'm going to square my 1 over 20 and bring it outside with the pi, so that is pi over 4. Trying to double check my arithmetic. Yes, we're good. And then you have to expand the binomial square before you go into integration, because you can't u-substitute what's in there. So expanding, I have 9 plus 6h squared plus h to the 4th power. And then I'm ready to integrate. And then you're almost there. At that point, you just need to plug stuff in and know where you can call it a day. So I plug in the 10. Let me see. I'm just going to reduce because it bugs me otherwise. And then cubing 10. 1, 2, 3. And 1, 2, 3, 4, 5. And then when I plug in the 0, I get minus 0. Don't go any further. Oh, then again, you can, but it's at your own risk at that point. You do not have to say minus 0. That's an important question. You just have to have a correct answer to that integral. Okay, so moving on to part C. I'm going to erase this so that I've got room to draw. At what point did you realize this was related rates? Or did you? Because there are just those moments where you're reading it and then you're like, oh, it's you again. For me, I see it when I see the phrase, at the instant when the height of the liquid. That's just like very common wording. But I want to point out to you that it says at the instant when the height of the liquid is h equals 3 inches. That is your when information. At least that's what I call it. That is something that you cannot use until the very, very end, because if you plug it in early, then it's not allowed to change, and it's supposed to be changing. So you are told at the instant when h is 3 inches, the radius of the surface of the liquid. So surface of the liquid would be the circle, and this r right here would be the radius of that surface. It is decreasing at a rate of 1/5 inch per second. You have to make sure that you recognize the word decrease and put a negative with your rate of change. At this instant, what is the rate of change of the height with respect to time? Whenever I do related rates problems, I'm looking for what is the rate of change with respect to time that they gave me. Is there more than one? What is the rate of change that they asked me to find? Then I look at who these variables are that I'm finding the rates with respect to time. And I make sure that I have an equation involving those variables and not involving other variables that I know nothing about the rate of change with respect to time, and I'm not asked to find the rate with respect to time. So they just flat out gave you the formula to use right there. So it is time to implicitly differentiate. On the left side, it's just r. So the derivative of r with respect to t is dr dt. Constant multiple 1/20th. And then in the parentheses, derivative of 3, 0. Then the derivative of h squared with respect to time, and you've got to use the chain rule. With the chain rule, I call h the bleh, the inside function. Derivative of bleh squared is 2 bleh times the derivative of bleh with respect to t. And when you think you are done with your implicit differentiation, double check that both of these rates of change came out. Often I'll see people's tests and they don't have all the rates of change involved. If you take a moment to check and you notice that you don't have all of them, you've got to remember you are differentiating implicitly with respect to time. R is not time, H is not time. Both of them have to be dealt with as chain rule functions. And DRDT didn't need to chain rule because if you found the derivative of R with respect to R, it'd just be times 1. So now it's plug and chug time once you have gotten this differential equation. Now you can plug the when information in. When H is equal to 3, and we are given DRDT is -1/5, and we're asked to find DHDT, so we're almost there. And at this point, do as little arithmetic as possible. In fact, you may even want to just go, hey, that divided by that, and then also divided by 2 times 3, 6, and that's DHDT. You literally can leave your answer this way, unless it really bugs you. But just avoid arithmetic the best you can. Then the answers, just to show you the answer key. And by the way, the website that I linked you to, if you go to, this was a 2016 free response question. For each one of these, scoring guidelines is what you're looking for the answers. They give a whole bunch of information. You can always look at that, but the most important thing are scoring guidelines. You click on that, and then you go and find the particular question, number 5. And then you can see the points and how they were allotted. So for A, 3 points, 1 for the integral. So that's the whole setup of the integral. 1 for correctly doing the antiderivative and getting, I'm going to see if I can, oh yeah, I can like do control click and that'll. So getting this right here, that's the antiderivative they're looking for. And then the answer is getting at least 2 plugging the number in and having this, or even going as far as this. It did not say to include units in the answer, so you did not have to put inches, so know that. But that doesn't mean you can't put units, just be correct. Okay, for part B with volume, only 1 point for the entire integrand. The integrand would be referring to everything here, including the pi, but not the 0 to 10. And then, because basically if you got 0 to 10 wrong, you got it wrong in part A. If you use the same H values in part B, then it's considered correct from there. The antiderivative, so basically this right here, and then the final answer. And again, they didn't say you had to put in the units, and you can stop over here before doing the arithmetic if you want. In fact, I'd advise it. Then 3 points over here, chain rule, worth 2 points. So that's a very big deal to them, properly using the chain rule. And then just getting a correct answer in whatever form you have it in. And it didn't say to include the units, so you didn't have to have inches per second. You do have to put in units, but they tell you when. They will say include units in your answer. Specifically, they will tell you that in the part, like in part A. If they wanted units, they would have said find the average value of the radius of the funnel and then include units in your answer would be said right after that. Okay, I'm going to stop recording.